Okay, good morning, students. This is a class of geotechnical engineering. So today we'll discuss about uh, a classification system of soil. It is already mentioned in the before in the previous classes, but we're going to explain today. Uh, we're going to discuss in detail about unified soil classification system. Okay, so let me first share my screen. Okay, my screen is visible, right? Okay, so here you can see this tabular format. This is a unified soil classification system. Different soil uh, may be represented by different symbols. Okay, we're going to discuss about how these symbols are represented. Okay, so yeah, so here you can see unified soil classification system. Okay, this is one of the system that can be used for the classification of soil, and it is also used in India. Okay, so this this screenshot is taken from a book named Soil Mechanics and Foundation by Dr. B.C. Purmia, Ashok Kumar Jain, and Arun Kumar Jain. Okay, so this screenshot I have taken from this particular book. So you can also go through this B.C. Purmia book for this content. Okay, so here you can see the title is given the Unified Soil Classification System. So yeah, it is written here. It was originally developed by what? Developed by Casagrande. Okay, even Casagrande also derived that liquid limit of soil. That Casagrande apparatus. I think you already heard this term, Casagrande apparatus, to determine liquid limit of soil. That was also proposed by the Casagrande. Even the Unified Soil Classification System, in short, USCS, it is developed by Casagrande in 1940. Okay, okay, and before it was used for the airfield construction during World War II. Okay, it was later, that is in 1952, modified by the Bureau of Reclamation and Corps of Engineers of USA to make it applicable to other construction like foundation, art dam, art canal, art slope, etc. Fine. So finally, this system also been approved by the American Society of Testing and Material, ASTM. It's a very famous and very well renowned organization. Okay, you have to know, you should know this American Society of Testing Material, ASTM, and later by Bureau of Indian Standard, that is BIS, our Indian Standard Code. Okay, in 1970. Okay, so here you can see according to USCS, that is according to this classification system, the coarse grained soils are classified on the basis of their grain size distribution, while the fine grained soil, whose behavior is controlled by plasticity, are classified on the basis of their plasticity. So, as we already discussed in the last class, the consistency index, that is liquid limit, plastic limit, shrinkage limit, all these things are related to what? These properties are for XNR. Yeah. So as you already know that this plasticity is a property of what type of soil? It is a property of fine grained soil. Okay. That's why for the classification of fine grained soil, this property is used. That is plasticity. This property is used for their classification. Fine. So basically, unified soil classification system is divided under two head. One for coarse grained soil, okay, and another one for fine grained soil. Okay, so there is a different classification for coarse grained soil and a different classification for fine grained soil. Okay, so here in this tabular format, you can see some symbols that I think this is already discussed with you, but still I want to discuss here. Some prefix are fixed for some particular type of soil. Okay, you already know what is gravel, sand, silt, clay, organic soil, peat. Okay, fine. Peat is a mostly highly organic soil. Okay, in peat type of soil, the organic matters is more than 50%. Okay, highly organic soil. Fine, fine. Okay, so these gravel are Soils is denoted by this capital G symbol, sand is denoted by capital S, silt is denoted by capital M, clay is denoted by capital C. If it is an organic soil, it's denoted by O. If it is a peat soil, then it will be denoted by PT. Okay. Wait, someone is waiting. Okay, fine. This is a prefix used for the type of soil. Okay. Now there is some subgroup depend on the behavior or types of the soil. Okay, a soil may be well graded, may be polygraded. Okay, now we'll define what is silty soil, what is clay soil. We'll go to discuss about this, but till now we'll discuss about here only. Now WL represents what? Your liquid limit. Okay, liquid, if liquid limit is less than 50%, what will be the symbol? If liquid limit is more than 50%, then what will be the symbol? This all are represent here. Okay, if the soil is well graded, then will be denoted by a suffix capital W. For polygraded soil, it is capital P. Silty soil, capital M. Clay soil, capital C. If liquid limit is less than 50%, then we'll say low. L for low, okay, means low plasticity. Okay, and if liquid limit is more than 50%, represented by capital H. H for high, high plasticity. Okay, remember L for low, H for high. Okay, these are some symbols that are going to be used for the classification of coarse grained soil under Unified Soil Classification System. Okay, now we'll first discuss about coarse grained soil. We already discussed about what do you mean by coarse grained soil. If more than 50% of the soil retain on uh, your 0.075 millimeter IS sieve, and it is also given by a number, that is 200 number US sieve. Okay, so it is, you can also represent by 200 number sieve or by the size of the sieve, that is 0.075 millimeter size. Okay, it is designated as coarse grained soil. Okay, now I'll just shift to the next picture. Okay, let me zoom it. Okay, okay, so the definition of coarse grained soil, it is already given to you. I'm not going to repeat here again. Okay, now coarse grained soil again divided under three types. Three types. Okay, classification is done of coarse grained soil is under three types. Okay, one, if the coarse grained soil contain more than 12% fine grained soil, it is a number one. Number two, if the coarse grained soil contain fine grained soil less than 5%. Okay, and third one is what? If the percentage of fine present in the coarse grained soil is in between 5 to 12%. Okay, from the first thing, from here only you can understand. Okay, now you can see, I think it is written here, coarse grained soil containing less than 5% fines. Okay, so it will, let's take it's a first types. Okay, if the coarse grained soil contain less than 5% fines, okay, then that type of soil is designated as what? GW or SW. If your coarse grained soil is gravel, if your coarse grained soil is gravel, then the soil will be denoted by capital G, G for gravel. And if that gravel soil contain less than 5% fines, fines means fine grained soil. Okay, it may be clay, it may be silt. If it contain less than 5% fines, then it may be denoted by a W. W represents what? Well graded. Okay, that means the soil is a well graded gravel. If the coarse grained soil is your sandy soil, then if your sandy soil contain less than 5% fine grained soil, then that type of soil may be represented by capital SW. That means well graded sand. Okay, now you also know how to differentiate between gravel and sand, isn't it? It is written here, a particular soil is designated as gravel if 50% or more of the coarse fraction, that is plus 0.075 millimeter, is written on 4.75 millimeter IS sieve or number 4 US sieve. Otherwise, it is termed as sand. Okay. I think from the table that we have already discussed about the type of soil. From the table, we will differentiate between gravel and sand. But both are categorized under coarse grained soil. Okay. I think it is clear here. A soil, a coarse grained soil, it a coarse grained soil may be gravel, may be sand. First thing. Okay. Then you have to check whether the particular coarse grained soil contain less than 5% fine grained soil or not. If the soil contain less than 5% fines, then we can denote it by GW or SW, depending on whether it is gravel or sand. Okay, well graded gravel or well graded sand. Fine. And if they are well graded, means if from the sieve analysis that we already discussed in the last class, isn't it? From the sieve analysis, from the curve, we'll get whether the soil is well graded or poorly graded. Okay, from the sieve analysis, you will get whether the soil is well graded or poorly graded. Okay. Now from there, if the from sieve analysis the soil is come as a well graded, then we have to designate it as W. And if the soil is poorly graded, then we have to designate it with P. Okay, then it come GP or SP. That means polygraded gravel or polygraded sand. If they are polygraded, simple is that. Okay, I think it is up to here. It is clear. Okay, if you have any doubt, you can also raise your hand or you can also ask me. Okay. So next, if however the percentage of fines are more than 12%. Okay, now same type of soil, you just consider same soil, and if this type of soil contain more than 12% fine grained soil, then you have to say the coarse grained soil are designated by the symbol GM or GS. That means if the presence of fines is more than 12%, then the effect of fines, we have to consider the effect of fines in that type of soil. That means we cannot ignore the presence of fines if the percentage of fines is more than 12%. Then we have to find out whether the fine grained soil is clay or silt. For there we have to go again for sedimentation analysis for separation of silt and clay. Okay, so from laboratory experiment we can also find out whether the fine grained soil is silt or clay. If the fine grained soil present in your uh, soil is silt, then you have to represent by M. And if the fine grained soil present in your sample is clay, then you have to represent by C. Okay, but it should come after capital G or after capital S, because main soil is what? Main soil is coarse grained soil. Okay, the more than 50% soil is contained by the coarse grained soil. That's why the first term is given by the majority soil. Okay, that means G will be come first or S will be come first. Okay, and after S or after G we have to put M or C. That means if the soil is contain clay, then we have to put SC. If the soil contain M, that is silt, that we have to put MSM. That is, now how to pronounce this? Suppose SM, a particular type of soil is denoted by SM. That means you have to understand it is the soil is known as a silty sand. If the soil is denoted by SC, we can term as clay sand. Okay, and from the symbol only you have to understand. Suppose we have in a particular exam the soil type is given as SC. Okay, you have to understand. Okay, so this soil is mainly a coarse grained soil because S is coming first. S stands for sand. More than 50% of the soil is sand. Fine. And this soil also contain more than 12% of clay. That's why the C is coming here. Okay, clay, sand, silty, sand. Similarly, clay, gravel, silty gravel, and clay gravel. Okay, I think up to here it is clear. Next, a third case, if the percentage of fines lie between 5 to 12%. Now we have already discussed when, how to represent the soil when the presence of fine is less than 5% and when the presence of fine is more than 12%. Now what about the intermediate portion? If the percentage of fines lie between 5 to 12%, then the coarse grain soil are designated by a dual symbol. Okay, that means you have to consider the case 1 and case 2 together. Okay, now you can see this the dual symbol is represent here. Okay, now just seeing this symbol, you have to understand this type of soil contain presence of fines in between 5 to 10%. Now how to understand this? Suppose this soil GWGM. Okay, there is just dash is given here. Okay, GW dash GM. Now from this symbol you have to understand the soil is gravel. First thing, be more than 50% of the soil is gravel, coarse grain soil, and it is gravel. Okay, now it is also represented by well graded gravel, and uh, M stands for silt, right? So it is silty gravel. Okay, so from this symbol, so from this dual symbol, you have to understand that this dual symbol represent it is a coarse grain soil, and it contain presence of fines or fine grain soil in between 5 to 12%. Correct? So like this, a coarse grain soil are classified based on unified soil classification system. Okay. Now if I come to this second, that is classification of fine grain soil. Now in the very beginning, we already discussed that fine grain soil are classified based on their plasticity. Okay, they are not classified under particular size. They are classified under their plasticity characteristics. Okay. Now, first of all, you have to know fine grain soil are divided under two type of soil mainly. Okay, one is your clay soil, another one is your silty soil. Okay, clay and silt, and it may also contain organic matter. Okay, so organic matter or organic soil also classified under this type of soil. Fine. Okay, so to classify this fine grain soil, Casagrande have proposed this chart. This chart, I think you can see this chart, this tabular format. This graph is proposed by this Casagrande. Okay, and it is known as Casagrande's plasticity chart. Okay, and this is the chart. In the chart, you can see the variation of what? Plasticity index in y direction, and in x direction it is liquid limit. Okay, so from a particular soil, from the laboratory test of a particular fine grain soil, if you can find out liquid limit, plastic limit, okay, then at least you can find out a plasticity index. That is what? Liquid limit minus plastic limit. That is already discussed in the last class. So we can find out plasticity index for a particular soil. We can also find out liquid limit of particular soil. Okay. Now, what this tabular format represents? Okay. Now here you can see at x-axis this is represents what? Your moisture content. Okay, that is you can say liquid limit. These all are represent liquid limit. Okay, and on y-axis represents your plasticity index. Now here two lines are divided the curve. One is vertical line at 50% liquid limit. Okay, this line is like a boundary line. Okay, the line uh, crossing this liquid limit at 50%. Okay, that means it's divided this graph in two part, this left side part and right side part. Okay, right hand side part, left hand side part. This zone, this left zone is represented by low plasticity zone. Okay, this right side zone represents high plasticity zone. Okay, so here you can see this L everywhere it is L represent at the second position. You can see L here everywhere. So L represents your low plasticity. Okay, now in the right side, all are represented by H for high plasticity. Okay, so this line, this vertical line divided this low plastic zone to high plastic zone. Okay, now this inclined line, I think you can see this inclined line starting from this 20 percentage of liquid limit. This is an inclined line and it is known as what? A line. Remember, okay, this is a line. Why it is called A line? It is denoted by, it is given by this A Kasagade. The Kasagande's total name is some starting from A. Okay, that's why represent by A line. Okay, and the equation of this line is what? IP, that is plasticity index, equal 0.073 within bracket liquid limit minus 20. Okay, it's a very important formula. It is important equation. Try to remember. Okay, in some exam, it's very it is usually asked. Okay, this equation IP is equal 0.73 within bracket liquid limit minus 20. Okay, now if you put, okay, now you can see it is starting from this point 20. Okay, and it is inclined going in this direction. Now what is the significance of this A line? It do what? This line separated clay soil from silty soil. The zone above this line, this zone is for clay soil. The zone below this line is for silty soil or organic soil. Okay, fine. Okay, so I'm just going to read here. A soil is termed as a fine grained soil if more than 50% of the soil sample pass through number 200 USC or 0.075 millimeter ISC. Okay, fine grained soil are subdivided into silt denoted by capital M and clay, okay, denoted by capital C, based on their liquid limit and plasticity index. Okay, organic soil also included in this group. You can see organic soil OH OL, it is represented here. Okay, so figure this showing this above, this figure shows the plasticity chart derived by Casagrande in 1948. Okay, and used for a USCS system classification system. The A line in the chart has the equation 0.073. Here you can see 0.073 liquid limit minus 20. This A line generally separates more silty like materials from those that are silty. That means it's separate from clay soil from silty soil, and also the organic soil from the inorganic soil. Okay, so you can see it is the organic soil. Here you can inorganic soil. Okay, yeah, the fine grained soil, that is silt, clay, or organic soils are further subdivided into soil passes for possessing low or high plasticity. Okay, when the liquid limit is less than 50% or more than 50% respectively. That means the soil is again classified based on plasticity, that is high plasticity or low plasticity, by this line, vertical line. Okay, fine. I think it is very simple to understand. Okay, you can read all these things. I don't want to, go through all these things. So fine. So I'm just giving you one example. Suppose you are consider one soil sample you have tested in laboratory. From the laboratory test, you have got the liquid limit of particular soil is anything. Suppose I would say 60%. Fine. So let me tell you, there's, let's say you have got a liquid limit of a particular soil is 60%. Okay, and your plastic limit also you got something. Finally, you have got a plasticity index of particular soil is say 40%. Okay, now when you have got liquid limit of particular soil 60%, that means it is higher than 50%. That we can say the soil is of high plasticity because it is beyond this, in this zone. Okay, in this zone. Fine. Now when you got liquid limit 60%, it will be here, and plasticity index 40% here. So let's come in this direction, and from here direction it will come here, isn't it? Okay, so from this point liquid limit of 60% and plasticity index of 40%, the point come here, join here. Okay, so this point represents where it is under this zone. So that means this point is on the right side of this vertical line and the above of this A line. That means it is denoted by CH. That means highly plastic clay. Okay. Similarly, if the soil parameter, liquid limit and plastic limit value find here, that means we can say low plastic clay. Okay. Similarly here, highly plastic silt or highly organic soil. Okay. Now here, low plastic silt or low plastic organic soil, like that. Fine. But in this chart, one special zone is here in the hatch zone. You can see here from 4 to 7. Okay, for 4 to 7 of plasticity index, and from 10 to almost here up to 30. Here you can see this is a special zone where a double symbol is given. That means in this soil, if your soil parameter come under this zone, the soil may be denoted by a dual symbol. That means you cannot say exactly whether it is clay or silt. You can give a both symbol. That means a clay, it may be clay, it may be silt. Okay. Okay. So it can be represented by low plastic clay and low plastic silt. Since it is on the left side of this line, so it will be L. Okay. It cannot be H. So low plastic soil will be common. L will be common, but it is also denoted by C and M. Okay. Fine. It is, I think it is written here somewhere. Let me check Twitter. Yeah. Yeah. For example, symbols like okay, here. When the plasticity index and liquid limit plot in the hatch portion of the plasticity chart, the soil is given dual symbol, that is CLML. Okay. Soil possessing the characteristics of more than one group are termed as boundary soil and designated by dual symbols. Okay, so they are represented by dual symbol and given by a boundary soil. They are termed as a boundary soil. That means it is under the boundary of clay and silt. Fine. So this is all about your classification of fine grained soil. So after this, finally, we can find out or we can understand this tabular format. Okay, I'll just want to zoom here. It's way too much. So this kind of table you can find in any book. Okay, try to understand this. So this is a overall summary of the unified soil classification system. This one for coarse grained soil, and this one for fine grained soil, and for it is highly organic soil. Okay, so definition is also given here. Okay, what is the region for given, how it is given GW, why it is given GP, everything, every details all are given here. Okay, whatever I have discussed till now, all these things are summarized in this tabular format. Okay, how to classify it is whether it is well graded or poorly graded. This also given here. Cu is more than 4, Cc must be in between 1 to 3, like that. Okay, it's for gravel. For sand, Cu more must be greater than 6, and Cc must be within the limit of 1 to 3. So all these things it is given here. It's better if you can understand this table, so it is very useful for you. Okay, so this can be find in any type of any soil mechanics book. So I have taken this from BC Punmia book. Okay, it's better, you can also refer there, you can also look in there. Fine. So I want to close here. Is there any doubt? You can ask me any doubt. So even after the class, if you just go through the textbooks, try to understand the unified soil classification system. If you got any doubt, you can ask me. Okay, it's not mandatory कि अभी पूछना है, बाद में भी पूछ सकता है. It's okay. Okay, first let me first stop my recording now.